All right, so honesty moment. Requirements are going to change. It really doesn't matter if you are in a highly regulated industry that has very firm requirements that get handed to you. By the time you're done, things will have changed. Now, it is inevitable, but also usually these changes are for the better. So it's a beneficial opportunity, and I like to be able to embrace these changes and as exciting improvements, and not as water cooler moments to tell someone about what dreadful thing happened. All right, so I have just two sections. One is planning for change, and the other one is coping when plans change. So the biggest thing about this section is awareness at the outset of the project. Evaluate your project, evaluate your customer, and try to predict the direction of changes. And that will help you choose a design, choose a hardware platform that will accommodate those changes in the future and will be a lot less painful. So, evaluating the environment. So, obviously the first thing is like, what type of project is this, right? Is it a monitoring project? Is it automated test? Is it a closed-loop control system? That's going to be your primary parameter for what design you pick. But beyond that, then you need to look at how well has the customer prepared you for this project. Are the designs and requirements firm? Are they not written down anywhere and they're just known by this one guy that will tell you as he remembers? Are you simply replacing an existing function? Then that's much easier to plan for compared to an exploratory endeavor that you should expect a lot of change. And likewise, you want to evaluate your customer, right? And whether your customer is internal or external, I do consulting, but all of you have a customer, right? Are they highly involved in the details of how you're going to do this? That's very different than if they're a very high-level visionary type customer that is just looking for future functionality and, hey, how can we make it better? How can we make it better today? And then, are you working with a coherent team, or are all the people on the customer? Sorry, this is the customer team. Are all the people on the customer team in their own little silos, or are they all very well integrated and highly communicative? Is your customer already discussing, changes and additions? This will be a really strong signal, of course, of the direction that things are going to go. And who is your customer's customer, right? What do they care about? What are they trying to accomplish? What do they want to achieve in next year's performance review? All right, so you take these things together and evaluate what your customer's needs are. I've done a lot of aerospace and defense projects and regulated industry projects, and for the last year and a half I've been doing a large project for an R&D research group, doing a fundamental physics energy research. These guys are really smart, they're highly dynamic, and almost every day I hear, do you know what we saw last night? Let's try this, right? And so that is a very, very rapid change. Trying to define a requirements document is pretty futile in that kind of environment. My boss went crazy trying to figure out, are you doing well? Where are your milestones? They're constantly changing or disappearing. So start by looking at the trends of their needs and extend that view to the future. So if they're frequently changing measurement instruments, then you want to have a strong OO hierarchy, maybe a nice plug-in architecture. If they are scaling the number of systems or test stations, then you want to start looking ahead at Eventually you're going to have some data management, right? You're going to network all these systems together. How are they going to communicate to each other? Probably you'll want an overall monitoring application that will watch all these systems. And if you're doing experimental prototyping, then modular software, very flexible hardware platforms, whether that is a PXI chassis that you can put any kind of card into, or you have a bunch of small, like C-RIO nodes spread around that you can just plug another module into. Those are all things that will help you choose your platform and architecture at the outset of the project. All right. So what we're trying to do here is predict our vectors of change, right? And it's important that you also discuss this with your customer. If there's a program manager that you're not getting to speak to, schedule some time with this person. Explain that I'm not trying to upsell you on more features. I'm trying to appropriately choose something that will save you money and time as things change in the future. Discuss it with your own personal software team, right? Because they're going to have ideas of how they will want. They're going to have ideas of how you can structure it, and hardware you can choose that will facilitate those changes. And they have a stake in it, right? They're going to be the ones that have to make the changes. So let them make it easy on themselves. And I also wanted to clarify, this is not about building in a lot of foundation that can do anything. This is just about picking a pattern that will allow you to do it in the future, right? So we're designing for the future, but we are not doing extra implementation at this state. Because things might change, but then again, they might not. It would be wasteful to go ahead and put in a lot of work right now for the future, especially the more dynamic environment you have. Yes, I made that up last night. Oh. All right, so a little bit of reiteration. We're going to design our solution with openings to address likely change vectors in the future. If they're going to be adding a whole lot of functionality, then you want to make sure you have good code modularity, so you can just add another code module. If they are likely to change the types of measurements that they're taking, or increase the number of measurements that they're taking, then you want to pay attention to your hardware scalability and flexibility. If they're likely to want to increase performance, right? Will want to run this faster. They'll want to have larger data sets. Then you will want to make sure you have a lean code architecture and probably some good memory management practices, and you also pick more task-specific hardware, right? If you're doing a closed-loop control system, you want to do RT or FPGA, right? You're not going to just do Windows with a bunch of asynchronous loops. And then another thing that is very frequent is your test process throughput. Like, we want to test more things faster. Then you'll look at our plan for adding additional test fixtures or test systems that will communicate with each other. You can offload things to subsystems if you need to, but think about that growth direction as you're planning. So it's really about not designing yourself into a corner. All right, so it's very simple. So selecting your architecture, right? We've all seen this kind of stuff. This is serial, a very serial architecture, and it's good for a simple application, something that you need to have a predictable timing about, and it's very easy to manage and maintain. And if your customer wants to own the code, then they can understand this pretty easily. let's say you need it to run faster. One option is pipelining it. This is the same steps, just each iteration of the loop does does all of the functions at the same time, and it will take 4 iterations of the loop before you start getting real outputs. But then, you're running at a faster rate. So this is good for deterministic applications, and it is easier to scale, add more modules, add more functions without adding significant more time like you would here. These are just simple concepts. Asynchronous agents. I have really enjoyed this recently. In fact, this is kind of the idea of what I based my architecture on for this R&D project. You have a bunch of agents that are running. They're all doing their own thing. There is some communication method between them. It's nice because, hey, you need a new functionality, you just add another agent, right? You need another instrument, you add another agent. All right, and there's many more architectures. I see command architecture, factory pattern, state machine, everybody knows that, producer consumer, decorator patterns, I'm not here to recommend any particular design pattern or architecture. I just want you to think a little extra when you start your next project. And no matter which architecture you pick, code modularity can give you really good benefits. You can grow by modules if they are coherent and not coupled to other things. Then it's great for team development because different guys can work on different modules. Unit testing and multiple instances. That's like, hey, I just added another oscilloscope, right? That module is a VI template. Just launch another instance of it. So duplicate needs or for performance throughput. But your code modularity is going to make it much easier for you to make changes in the future. All right, so I'm going to talk a little bit, I just have just 2 or 3 slides, about an architecture that I settled on with this R&D project, and it was very successful. It's very open to changing and adding, and I think it's rarely been the software development that has slowed down this research customer. It is much more the test time. So they can say, hey, I want to add this or do this, and in a day or a week, it's implemented, it's rolled out, and they're using it. So at the core, I have some launchers, and basically they're launching some asynchronous agents from VI templates. Okay, you have a whole list of instruments. And this is class-based, so so under the hood here, I have a single instrument agent that gets decorated with the instrument class and launched. And then, since I have one instrument agent and all the functionality is built into the instrument class itself, then it's nice. I end up launching like 100 different instrument agents that each hold the instrument class that defines its behavior. And then of course there's other ancillary agents. So an alarm agent, a logging agent, I have an error logger agent. There's a health monitor agent, and I settled, for this implementation anyway, I settled on user events for the messaging transport between all of the different agents. Now, so they are actually running experiments. There's an experimental procedure that needs to get done. It changes a little bit, not a whole lot. So we needed to make a test sequencer. You can imagine what that's like. It's just a scripted state machine of going to the next step. Now the steps are actually, all those test steps, we decided to do as classes. It makes it very easy to add a new test type, and all the functionality needed is very portable in that step type class. So some of the step types are operations, like set all the valves into these states, take measurements, do some data analysis, or set time markers for future data analysis steps, and generating reports and even messaging the operators so that they can wander off and they'll get an email that says, hey, your test is done and it looks good. And then we also decided to do classes for the data types. So that those data classes contain the type and other behavior information, like what format should this be in when it gets logged, right? If you have a 1D array of data, you can log it many different ways. Sometimes it's just, hey, this is the last 5 minutes of pressure data. Sometimes this is a spectrum from a spectral analyzer that is not continuous in time, and you need a discrete record each time. But when they come into the logger, they're both 1D array, right? So the log format can be built into the data class itself. And then other things like data reduction methods. If I'm oversampling, do I want to take a rolling average? Do I want to decimate and only log every 10th point? And that can all be built into the data classes also. Now this is something that's pretty simple, but man, I've gotten a lot of mileage out of it. And I don't know why I didn't do it before. Okay? While I'm launching all these agents, my GUIs can be agents. They can run in the background. They're launched by reference, and they just run in the background. I have a sub-panel on my main GUI, and as the test procedure demands or the operator demands, they can snap those GUIs into my sub-panel. So it's actually a separated view, and it wasn't hard to do. Then one of the nice things is, since they're always running in the background, you don't have gaps in time, right? So even if it's not frontmost or in the sub-panel, it's still populating my pressure graphs. So when they pop it in, it still has the last 2 hours of data already in it. And then, like most big systems, there's a bunch of ancillary support utilities, like hardware configuration, software configuration, setting your alarm responses, test limits, data viewers, report generators. If they, this is one of the things that we wanted to add because their methods of data analysis are also changing. So let's say they said, oh, we figured out that we should have analyzed it this way. Well, I want them to be able to go back and rerun from the raw experimental data all the reports for the last week with the new data analysis method. All right, so this enabled a lot of change and very rapid change, right? We need a new measurement. I want a new flow meter, LCR meter, whatever it is that they dream up, right? I can just create another instrument agent, another instrument class, just launch another instance of the instrument agent with that class, and we're off to the races. Different logging formats I mentioned. We can add that into the data type classes themselves. Alternate views and create another GUI agent, right? Not most people, let's say they're doing some optical alignment, and they say, it's really hard to see from across the room how to maximize that graph, right? Or maximize the signal on that graph. Well, let me make you an alignment GUI. It's just a giant graph with a big, thick line that you can see from 40 feet away. And you need a new report or a report subset of the report, a new analysis algorithm, a new operation, then just create a new test step type. And then you need to expand to more test stations or more fixtures. We actually encountered this. We started with a single test sequencer that was in our main GUI, and instead what we ended up doing, they said, hey, can we run 3 test fixtures instead? And I said, yeah, I think so. It's a little bit more hardware. And in software, all we ended up doing was taking the test sequencer itself and putting it into an agent. And now I can launch 3 of them for the 3 test fixtures. We're now up to 24 test articles that can run concurrently just through all these agents. We have about 200 concurrently running agents in this application. Now, sometimes things don't go as planned, no matter how well you planned. So there's some easy things that might seem expedient at the time that you can do. If you are needing to add new functionality, you can offload it into new software modules similar to what I described, if that works for you. You can add an additional hardware platform. Maybe you have your main PXI, and you're like, oh, I'll stick a compact DAC over there to take that measurement, right? You can change your architecture a little. It's pretty easy to make a serial architecture into pipelines. You can stage processes for idle time, right? Like, oh, I'll do that data analysis after I'm done collecting all this stuff, or I'll log that, when we're pretty much idle. These are methods, they work, but they're more about patching in. I don't know what button I pushed. Okay, they're more about patching in new functionality and don't really do anything for the technical debt that you've been building up. If you need to increase performance, that's very different. You don't want to just spawn off more code modules, right? You can start with code optimization. You can diagnose with the IDE tools your worst offenders for memory usage or processor time, and fix those things. And those are spot fixes. Sometimes that's enough because you can get 80% of the way with just a few bad spots. And then you really want to be resource aware, right? Data copies, managing your references, staging your execution so that if you're running things deterministically, maybe you want to offset your loops by a millisecond rather than all hitting at the same time. I do want to mention VI Analyzer can help you a lot with your optimization and your resource awareness. There's a lot of checks in VI Analyzer to make sure you've done very simple things like move that front panel control outside of the loop or that first structure on the block diagram. It's, you see it all the time in code that is delivered to you by NI, but that actually makes a really big difference when you go to compile. And then again, your code module coherence, improving that will often provide avenues for optimizing your code. And then, of course, you can always just buy faster hardware, right? But there's a limit. Eventually, you're going to hit a wall. Okay, so, Casey, is this 45 minutes or an hour? All right. So you are going to end up, or eventually you're going to end up needing to do some refactoring. Okay. Refactoring is needed when basically when there's something that you did wrong, but it could just be that you decided wrong, right? So if you have excessive module coupling, any changes are going to have a widespread impact all over your code base. That's something that will require refactoring for you to be able to continue growing and changing your code base. Inappropriate abstraction. Especially new OO developers, they get into like this encapsulation slavery mode, where it's like everything has to be inside here and hidden, and sometimes you might need to refactor to change the scope, push things up a level, down a level in your OO hierarchy to match your needs. I think, that was my next point. I think we've all looked at our own OO hierarchies after they've grown and realized, wow, that is a super gargantuan cluster, and I just inherited a garage full of crap that I didn't need. Excessive delegation, poor data organization. These are all incorrect public-private scopes that allow others on your team or yourself to abuse your interfaces, or you just grew the code into a bloated mess. And that one is kind of the hardest it's the easiest one to point at, but it's the hardest one to control as you're going, because it just kind of sneaks up, right? It's just accumulating. Okay, so not patch fixes, but actual refactoring methods. There is a site, sourcemaking.com, that has a nice high-level review of a bunch of these methods and the causes for bad code smells. Some of the refactoring techniques are recomposing all your methods, right? Streamlining them, removing duplication, redistributing your functionality among your classes, because as your OO hierarchy changes, sometimes you don't always keep up with rearranging where methods exist. So do that so you can find what you need where you expect to find it. Reorganizing your data will improve your class portability and reusability. Simplifying your decision trees, improving method interfaces. These are all real refactoring methods, and I'm not going to go through all of them, of course, because I don't have time. But sometimes you cannot avoid a rewrite. The most common reason that you have to rewrite is that the architecture or design pattern that you chose will not accommodate the change that is requested. My biggest project failure was due to incorrectly predicting what direction things were going to change. It started as effectively a monitoring system with some light control outputs, and after about a year, they changed it to a closed-loop control system. And a monitoring system, I don't have all the requirements. I'm just going to launch code modules, and as they tell me what needs to run, but there is no end-to-end determinism in that kind of structure at all. It was like they said, build us a car, and you did really good work, y'all have all done this, and then your customer says, now make it submersible. Sometimes there's no recovery. You have to do the rewrite. So, key takeaways: evaluate your project and your customer. Predict your possible change vectors. Don't do a lot of implementation now. Just design for that implementation in the future. And have fun delighting your customer when they ask for things. And that is all. Question, Bob was first.
This is a meta question. Where do you get the service?
I got it from the NI PowerPoint template. That's where I got the survey. No, I'm sure this is in the NI app, the NI Week app that you can download.
So I have the app, I'm using it, but I've never seen, I probably
Yeah, I believe you select this session, and then there's a survey option. Okay, serious.
You mentioned something I never thought about, and that is having an agent for the display, for the booth. And my question is, if I say I have 30 test agents, each one of which I want to potentially show,
Not that one.
that I want to potentially show, so I have, if I had them all up, they'd be 30 graphs going. Which could take a fair amount of time. If the agent is not displaying in the front panel, is it taking time making to use?
Okay, that's an excellent question. So the question is, if I have all these GUI agents that are running in the background, well, graphs that auto-scale can be really expensive, right? Resource-wise. No, LabVIEW is smart enough to not update panels if they're not visible. So that's not something that you have to worry about. Y'all ask lots of questions.
I think Jeremy thought he was done earlier than he actually is, so I'd like to actually maybe go back a few slides to some of the things that cause us to need to do refactoring and talk about some of those things. You mentioned like inheriting a garage full of crap, right? So can we go back some slides maybe?
Yes, I will answer your questions last. No, yes, just 1 second. Dave.
So you refer to these as agents. Do you differentiate between agents and the abstract concept of actors?
No, it was just confusing to my, do I differentiate between agents and actors? No, it was just confusing to my team and they were all scared to use actor framework. So the point Steve is making is early on I said refitting or replacing an existing system is actually easier. Steve makes an excellent point. You should probably figure out if that system works and meets their needs. Lots of times they use it because that's what they had, and this is an opportunity to give them something better. All right.
Jeremy, could you go a little more into what code module coherence is?
So code module coherence, a very easy explanation or example is my measure method should not measure measure and decimate and analyze and spit out a processed number, right? My measure method should just measure. Those other things should be their own methods. It will make things much easier to maintain. It'll make it easier to copy. Your children classes will have much cleaner inheritances. You will have fewer overrides. And when one guy in your team needs to change something, he's not changing 3 people's code. Dimitri, I'm a little scared about your question.
Very simple one. Did you consider using actor framework instead of this? And if not, and if yes, why did you?
Okay, that is a good question. Did I consider using actor framework for this? Briefly, this has been going on for 1.5 years. When I started, for all I knew, it was only going to be 1 month. So this started, this grew. It was not a large system to begin with. It was a experimental prototype system with 1 test fixture. And actor framework takes a commitment to start, and I didn't think my customer was ready for that commitment. Also, they were already anxious enough about me just looking at OO code that I didn't want to go all the way.
Going back to the increased performances, would you consider building your agents into PPLs, maybe even use coding architecture?
Okay, for increased performance, would I maybe move my actors into PPLs? Yes. Yes. So, Thijs, how was that? I'm thinking yes, because wow, that would make this really portable, reusable on my next projects, but I am running to keep up, and I have not had time to do that exercise. I was not aware that project libraries would increase performance. Is that something you've experienced?
Yes.
Okay, everyone take note. This is a new method.
Performance?
I mean, in terms of coding the entire application,
Because it's the same compiled code. Where do you gain?
you gain when you not especially use all your agents first. So maybe when you launch your application, you need 2-3 agents. So your application is lighter in memory at that time. And as you use your application, then you load the agents. And in the end, it's the same. But maybe there are some use cases where some of your agents are never used by someone.
So what he's describing is staging the launching of agents throughout your code, the way you would a plugin architecture, where, hey, I need this now I will launch it, rather than launching everything to begin with. There are some flavors of this, or some instances of this software application where we don't have a whole suite of sensors, right? We have a simplified test station that just has a subset, yes, doing that would save me from launching a lot of agents that never actually get communicated to. Somebody else had a question. John.
Yes. Just to add on what Thijs was saying, I think there's another type of performance increase, that's a development time. When you componentize your code, you end up with much more modular code, easier for you to change. So.
Yes, so the biggest performance benefit is your personal development performance. It will make it faster and easier to make changes. Casey.
I was just wondering if you could talk a little bit about when you went to the multiple racks and what refactoring was like in that instance. So you were at N1 and then you had to go to an array sort of solution. Like, maybe walk us through.
Okay, so yes, and there's a bit behind that. So going from one test station to, being able to test 24 articles at once. So first, the sequencer had to be spun off into, or refactored into an agent that I could launch. Some of my systems have 3 test stations, some of them have 24, so I can dynamically decide how many sequencers I need depending on the station that I'm on. There are shared equipment, shared instruments, huge power supply. I don't need more power supplies just to run more stations. They're just charging something up and they're idle. So that's an example of equipment that I need to have create an instrument manager for that would make sure that multiple people weren't trying to use it at the same time. You don't really need 24 $15,000 oscilloscopes. It'd be much better to spend 1 day of software time and save a lot of money and space. So part of that instrument manager also included the concept of equipment locking. I have all these sequences that are all running concurrently. One of them gets to a stage in the test recipe where the recipe itself will say, I need this set of equipment and I need to lock it for the next 30 seconds because these all work together. And then all my other sequencers, if they see the lock, they'll just wait and show on the front panel that it's locked by this other sequencer. This is how long it's been locked. And then as it releases, then other guys get to use it. Somebody was asking me why I didn't use active framework. The question I get more often is, why didn't I use testing? The primary reason is probably because, like I said earlier, it grew from a small application. The other reason is there is a lot of custom code that would not be as easy to generate, wouldn't be as dynamic if I was using TestStan as my test executive. I didn't talk about this, I do have a bunch of agents that are doing equipment monitoring and control, maintaining, I don't have this, but it's an example, maintaining a variable transformer state, that's the kind of thing, or maintaining pressure in a vessel with a pressure controller. Those all get launched and spun off and started. I didn't want it to be possible for my end user to blow things up because they forgot to put a step in the test standard sequence.
So from a business standpoint, you start and do a prediction of what the change vectors can be to the project, and suddenly the customer says, I want to change my car into submersion. And you find out my predictions are wrong. How do you communicate that to the customer? Because you did the wrong predictions. It will cost a lot of time and money. Who will pay for that? How do you...
So,
on the other side, the customer does a 180 degrees. So
it is a difficult conversation because effectively you're going to ask for more money, right? Because you had that frank discussion. You decided these are the ways it's going to change, or that's the way it could, what's what we could need in the future. But what your scope right now is the requirements you were given. And so even though you're trying to design for requirements you've never seen before, your deliverables are the things that were agreed on. And so if they change the requirements enough that you need to make your car submersible, then you have to have a difficult discussion with them and explain why it's going to take more money, more schedule, and get their team to understand and buy into that.
So would you take part of it? So only let them pay half the hours?
No, I think at the outset you have especially after you've done this, you have a pretty strong agreement that this is the current design. And so if they want to make it submersible in the future, that is a new project or a large ECM.
So that would mean that you communicate your predicted change factors to the customer. So you say, this is my architecture, I predict this would happen in the future, maybe.
So your customers are usually pretty smart, right? It's when you're doing these initial meetings with the customer, you're defining, you know, yes, things might change in this way or that way, or we might want to have more test systems, that kind of thing. You're actually speaking their language, right? They're looking at what they want to get done and what they will want to get done, not necessarily how things are architected, right? So when it gets to be a large enough change that your architecture doesn't fit the needs, then you have to sit down with them and say, all right, we had talked about this, I structured it like this, and you give them a little high-level overview of this is how it is under the hood, why this will not accommodate this change that you're asking for, and they're usually pretty understanding because you've had those conversations. Brandon.
Essentially this question, so one, I'm curious on this question, say, issue, explain what you're
No, this was time and materials, thank you. The question was it fixed price or time and materials? R&D environment, there's no way we can scope this, right? If I can't put a milestone on it or say what's going to get done and how long, then it's pretty much impossible to bid as a fixed price project.
So curious on your, how they handle the code change. Time to release it, but I'm curious on how you handle that effectively.
That is a good question and totally not software related at all. So the question is, fixed price, there's a process for a change, right? You do an engineering change notice or change request. And it's very well communicated. Time and materials, it's not as strict typically. You don't have not everyone has a process for communicating the cost of changes to the customer. In that environment, when the customer says, we want to try this, then my response is, okay, I think that will take about a day and a half with 2 people. You know, that's my schedule. Here's about how much it'll cost. I'll roll it out, y'all can try it. And then I just keep notes on these are decisions that were made. This was the estimate of cost, and periodically I send that to them, and thankfully they just keep adding money to the PO, and everything is great. Yeah.
Do
Yes?
you have all your agents in a single project, or one project per agent?
That is a good question. Do I have all my agents in a single project, or are they split up into projects for portability? I wish they were split into other projects.
For your team to love the project.
Yes. And if y'all have developed on teams, you know some of the pain points there. Source code control, how many people touch that VI. Even if that's another benefit for the code modularity, right? If it's very modular, then guys aren't touching code all over the place. They have very discrete changes. It's very easy to manage your team you go work on this logger, you work on this data analyzer, and they don't step on each other's toes. The project file itself is an issue, right? You add classes, class files also, any library file. It is a pseudo XML format that your source code control will attempt to merge and kill it, right? So we set our source code client to treat those as binaries and not do a text merge. It's not ideal, but I don't know how else to do it in graphical programming language. We have one guy that is kind of like, he's the manager of the project file, and if people need classes added, they just message him, and he adds the classes from the folders that they request. And that's about the best that we can do with that. But yes, if they were split into lots of projects, then I would know they were decoupled, and people could play with their own project files, and it would be better. Thank you for that.
Yes, have a kind of way of managing the project manage by using material. They have a branch on material which is what will make a change.
You should tell everybody about this.
Okay, so we have a workaround for the project merge. We don't merge the project file, but if you need to make a change to the project file, before you do it, you pull from the latest development branch, as a branch that no one else is supposed to be working in. It's like a pre-release branch. You pull that into your code, so you've got the latest released version of that project. You make your changes, you make sure everyone's okay, then you push it back into there. Then people can pull from there and fix their own problems as they go. So you never actually merge that file, but you manage it through the source code.
All right, so effectively, it's a very short-term ownership of the project file. So he has one a code branch in his repo that has the project file, and before you modify the project file, pull it from the repo and modify it, push it right back. If everybody follows that, unless somebody's doing the same thing in the same 5 minutes, then you probably won't have any problems.
So, just to add to that, I think the pattern is that if he said dev branch, so I'm thinking like the get flow style. So there's a master branch that you build off of, and then there's a dev branch that everyone sort of syncs with. And when you're in your own branch, you have to pull from dev first and merge dev into your branch, and then you can push your branch to dev. And
Yeah, I would love to do a whole session on source code control and Git flow, workflow. It's been delightful. It's probably the most significant change in the way that I work out of all the tools that I've used. LabVIEW upgrades, that's great. You know, I appreciate it, but that one was one that just like changed everything. So especially large team development. So check out just any distributed version control system if you're not using one.
I'm curious to see who is using Git.
How many people here are using Git or Mercurial? Okay, how many people are using the Git flow workflow? All right, that's excellent. When I first went from centralized to a distributed version control system, and like, wait, before all I had to do was lock it, and then nobody could change it, right? Now I look at this and like, how do I use this? What do I do? It's very wide open for a lot of different workflows. The challenge is getting your team to consistently use the same workflow. Once that's down, then there's lots of benefits.
How often do you do hand merges?
How often do I do merges, branch
Hand
merges?
merges.
And
Hand merges.
oh, hand merges. How? So we were talking about this last night. I've been using Git and the Git flow workflow for about 3 years, maybe 2 or 3 years. I've had to do a hand merge of LabVIEW code like 3 times. Yeah, it's not that often. You can set your client to launch LD compare. During the merge, your files are already staged in the staging area if you're familiar with Git, and so you can actually modify them. Right, you know, you can copy from this VI and paste it into this VI, and then save, and then your commit will have the merge code. So, but I will strongly attribute that lack of hand merging to modular code structure and modular team development, right? All right, any other questions?
Last question about the GUI agents.
Yes.
So is it updating from how it's not displayed and how it costs? Presumably you start to worry about how much memory they're using by having 58 versions of the same data potentially runs.
Yes, so back to having all these agents running in the background, especially the GUI agents. You may not have to worry about processor resources trying to redrawing graphs, but they still do take memory resources. And yes, that is intentional so that we don't have gaps in our data. The normal limiting your history on your graphs and charts, and just memory's pretty cheap. Stick a bunch in before you start. You're not going to grow that much, and this is one of those times where that patch of just buy better hardware actually is sufficient. And then, of course, before you deliver, check that you are not growing in memory usage. All right, any other questions?